Good afternoon, everyone. Let us start. Today we shall learn how to construct isoplane maps. Now let me present my screen. So remember, we have been learning chapter 3, graphical representation of data, and this is the seventh and the last session of this chapter 3. And about the meaning of isoplate, we have learned earlier. Okay, again, let me remind you, this isoplate is derived from this iso, meaning equal, and a plate means lines. So thus an isoplate, okay, is an imaginary line which join places of equal values. Okay, and today we shall learn how to draw isobars, okay, on the map of India. So isobar means an imaginary line joining places having equal pressure. So this is activity 14, and so we have the question here: draw isobars on the map of India shown in the following figure, on which mean monthly pressure in millibars for the month of July has been indicated for a number of meteorological stations. Okay, weather station, recording stations. So this is the map, and so these are the different okay, meteorological stations, recording stations, and these are the values of pressure in millibar: 845 millibar, then 681 millibar, and so on. And see here, you must know that here all the pressure values given here are reduced to sea level. Why it is reduced to sea level? Because see, as like temperature, pressure is also decreased rapidly with increasing height, and that is why we cannot compare these pressure conditions, okay, uh, between the stations before reducing to the sea level. Say for example, here we know that pressure decreases, okay, pressure decreases with increasing height rapidly. And here at the ground, at the sea level, the pressure may be 1013 millibar. And say after climbing up 1 kilometer, okay, so pressure may be here, maybe around 850 millibar. That means pressure decreases rapidly with increasing height. And accordingly, pressure conditions found at the recorded at the top of a mountain and in the low-lying area will be different. Okay. See here, pressure recorded here, pressure recorded at the top of the mountain cannot be compared directly, because we have learned that pressure condition is affected by altitude. And if you compare directly the pressure condition found here on the top of the mountain and at the low-lying area, the result will be wrong. Okay, so what we have to do is we have to convert the pressure condition found at the top of the mountain and this in the low-lying area to the sea level. Okay, to the sea level pressure condition. This is what we call reduction, okay, to the sea level uh, pressure condition. And now let us see here. So these are the different stations. Okay, see here, these are the dots. The dot shows the recording stations, and this value shows the pressure condition in millibars, MB. Okay, here we have the method of interpolation, that is how these isoplates are drawn. Okay, so here we are following. Uh, okay, we are following the steps given below. First, actually, we have to observe this map. Okay, the values plotted here, all the values plotted here must be observed very, very carefully. And after that, you may find minimum and a maximum values. Okay, then after that, based on the range, so you may, if yes, I told you in the earlier, okay, lessons, in the previous lessons, if the range is not great, is not big, then we may apply that formula used earlier, the technique used earlier. But if it is too wide, okay, then we may not. Simply by observation, you may determine the this class interval. See, first determine, okay, the minimum and the maximum values. Then based on the range, we have to determine the interval. Okay, here we have selected this an interval of 10 millibar. An interval of 10 millibar. Usually in the weather maps, okay, we use this interval of 10 only, mainly. That is why we have chosen this 10. Okay, an interval of 10. Then after that, see, it is better to draw the isoplats of minimum values first. First, we may do, for example, first we may draw, okay, 900 millibar. Then after that, we may draw 910 millibar like this. Okay, so on. We better to draw the minimum value first, and then other isoplats, okay, may be drawn accordingly. And for the this exact point of drawing an isoplate, okay, is determined by using the following formula. The exact point of drawing an isoplate, where to locate, say for example, this isoplate will be drawn here, okay, like this. And how to locate these isoplates, we use the following formula here. The point of isoplate is equal to distance between 2 points in centimeter. Okay, distance between 2 points here means here we have a point here, okay, having the value of 1004 millibar, and here we have another point here, 1010. Okay, distance, so we have to measure the distance using this ruler. So what is the distance between these two, this point and this point? We have to measure in centimeters. Okay, then what is the difference between the two values here? What is the difference between? We have to subtract this 1010 minus 1004. Okay, and accordingly you may get the difference between the two values. The difference between the two values of corresponding points. Okay, so 1010 minus 1004 is equal to 6. So the difference between the values of corresponding points is 6. And in this case, okay, this is just an example. In this case, it is 6. And here the interval we have selected 10. So after that, you will get the exact point of location of this isoplate map. So this is the map, okay, and let us see how this 1010 millibar isoplate is drawn. Okay, see here we have the 1010. Okay, so we may directly pass through here. So we may directly pass through here. Okay, and since 1006 is here, so we may cross it, and another 1010 is here. Okay, and you may touch it directly. And since we have 1000 here, then we have 1001 here, another 1001 is here, and then another station having the value of 1015 is here. Now let us consider these two. First of all, what to do? So we have to put the scale here. Okay, we have to measure the distance between this station, okay, and this station. And see, so this is West Bengal area, okay, this is west West Bengal area. And see, when we measure the distance between this point and this point, okay, it is measured 1 centimeter. Okay, then according to the formula, okay, we have to find the difference in values. We have to subtract it, okay, 1015 minus 1001, okay, multiplied by this interval. So we have selected 10 millibar. Okay, then after that, what to do? See here, 1 into this 10 is 10. Okay, then 15, 1015 minus 1001, we have 14. Okay, then 10 divided by 14 is 0.71 centimeter. That is 7 millimeter. Then we have to put the scale here again. Okay, so thus isotherm of this 1010 millibar is plotted. Okay, is plotted 7 millimeters away from here. Is plotted 7 millimeters away from this station, or 3 millimeters ahead. Okay, or 3 millimeters ahead of this 1015. So here, let me produce here. So this is station this 1001, and this is station 1015. So we have to put the scale here, and let us say the distance between the two stations we have measured 1 centimeter, and we have learned that 1 centimeter is equal to 10 millimeter. Okay, so here these are the marks, okay, in the mark in the scale. See, 1 2 3 3 4 5. Okay, let us say this is 1 2 3 4 5, 1 2 3 4 5, 1, okay, 2, 1 2 3 4 5. Then see, so to plot this 1015 isoplate, what to do? We have to measure 7 millimeter from this station. Okay, so here 1, then 2. Okay, actually this, let me put 1 here. 1 2 3 4 5 6 7. So here this is the exact point of location of this 1010 millibar. In other words, okay, it is 3 millimeters ahead. Okay, it is 3 millimeters. Say 1 2 3, 3 millimeters ahead of this 1015. So in this way, the exact point of location of isoplate is determined, and you have to apply the same technique for the other for the other stations also, for drawing isoplates of the other station. So any question from your side? Are you clear? Okay, then see, for drawing on the practical notebook, if you have printer, or if nearby your house, if there is any DTP shop, computer, okay, printing shop, then you may print this question paper, I mean this map, and on it plot it, okay, after seeing that answer given below. And this much for today, and thank you very much for joining my class.